Okay, let's continue. We'll study distance between points. So, consider points x1, x2 on the line. We can ask, what is the distance between the points? So we have seen how to specify points on the line. Now we are asking how can we find the distance between any two points on the line. So consider points x1, x2 on the line. What's the distance between the points? So you have two cases. We have two cases. The point x1 is less than or equal to point x2. So in this case, the distance is x2 minus x1. Right. So we have another case where the point x1 is greater than this point x2. So these are the two possible cases. In this case, the distance is x1 minus x2. So hence we see that distance between x1 and x2 is x2 minus x1 if x1 is less than or equal to x2, or if x2 minus x1 is greater than or equal to 0, and minus of x2 minus x1 if x2 minus x1 is less than 0, that is x2 is less than x1. So this is just by the definition of absolute value, this is the absolute value of x2 minus x1. So hence distance between any two points x1, x2 on the real line is the absolute value of x2 minus x1. So we know how to compute distances between points in the line. So now we can try to do the same for the plane. Consider points P equals x1, y1 and Q equals x2, y2. On the plane. So consider 2 points x1, y1 and x2, y2 on the plane. We can ask the same question. So what is the distance between the points? So we can draw a diagram for one case. So this is P, x1, y1, and this is Q, x2, y2. So we are interested in the distance between these 2 points. So we can draw this right angle triangle. So the one side of this, one leg of this right angle triangle is, in this picture it is x2 minus x1, and the other side is, the height is y2 minus y1. So this is picture for one case. this height is y2 minus y1 because the height of q is y2 and the height of p is y1. So the difference in heights is y2 minus y1. That will give this this vertical side of the right angle triangle. Similarly, the x coordinate of q is x2 and the first coordinate of q is x2 and the first coordinate of p is x1. So the difference will give the length of the other side of the right angle triangle. So hence by Pythagoras theorem, so distance between these points P and Q is just square root of x2 minus x1 square plus y2 minus y1 square. This is the distance between any two points in the plane. So this is for, the picture is for one case, but you can note that the result holds for other configurations. So for example, you can consider, so one of the many configurations, so you can consider this configuration. We can see that the same formula holds, just that you can construct a right angle triangle like this, and this height will now be y, this height is y2 minus y1 again, but this segment, this side will be now be x1 minus x2. In the above picture it was x2 minus x1, but here it will be x1 minus x2. But again you are squaring, and in the formula it doesn't make a difference. So distance between P and Q is square root of x2 minus x1 square. Whether you're taking x1 minus x2 square or x2 minus x1 square, it's the same thing. So it's the same formula. The same formula still holds, and it gives the valid distance between these 2 points P and Q. So note that the result is true for other configurations. We have checked one more configuration and the formula is still true. So distance between any 2 points in the plane is square root of x2 minus x1 square plus square root of y2 minus y1 square. So this is basically Pythagoras theorem in coordinate geometry. Okay, so that's all for this part. See you in the next part.